Okay, hello everyone. Today I'm going to give the proofs of some formulae which we have been using for quite a while now. So, yeah, the first formula is that the sum of natural numbers, right? 1 plus 2 plus 3, all the way till n, right? Till n term basically. That has to be equal to n into n plus 1 upon 2. Okay, so how do we prove this formula? Let's call this thing as S. Alright. And now I'm going to write s in a different way. I'm going to write it as n plus n minus 1 plus n minus 2 all the way till 1. And I'm just going to add these two equations. That will give me 2s is equal to n plus 1 plus n minus 1 plus 2 is n plus 1 as well. And then you can see that every pair does equate to n plus 1. So you have these many of n plus 1. How many of n plus 1? Well, there are n numbers over here, and each of them actually finds a pair. So there are n pairs over here. So this is n into n plus 1 equals to 2s. So s equals to n by 2 into n plus 1, just as we saw before. Okay, this was a pretty easy proof actually. The next thing is 1 squared plus 2 squared plus 3 squared all the way till n squared. That has to be equal to n into n plus 1 into 2n plus 1 upon 6. So that's the next formula which you want to prove. So this is not that easy to prove. You can either prove this using the general assumption that this sum is given by some kind of an expression in n, right? A cubic expression in n, but that's the lengthy way and the less intuitive one. So what I'm going to do is that I'm going to write it like this. I'm going to say that n cubed, instead of saying n cubed, let's say that r cubed maybe. All right, so what about this thing? Okay, so you will have yeah, r plus 1 cubed minus r cubed. Okay, what is that supposed to be equal to? That is supposed to be equal to, you got r cubed plus 3r squared plus 3r plus 1 minus r cubed. So this cancels, right? So first of all, just put the value of r as 1, or maybe before that, maybe we should put the value of r as 0. So that will give me 1 cubed minus 0 cubed is equals to 1. Okay, actually I should say 3 into 0 squared and stuff. Maybe not, maybe just put the value of r as 1. Yes, just go ahead and do that. So you got 2 cubed minus 1 cubed, that is equal to 3 times 1 squared plus 3 times 1 plus 1, obvious. Then you got 3 cubed minus 2 cubed when you put the value of r as 2, that is equal to 3 times 2 squared plus 3 times 2 plus 1. Then you got 4 cubed minus 3 cubed, that has to be equal to 3 times 3 squared plus 3 times 3 plus 1, and this keeps on going like that till you eventually have I think I should say n plus 1 cubed. Okay, n plus 1 cubed minus n cubed, that has to be equal to um, 3 into n squared plus 3n plus 1. So now just add all these equations up. So you can see that this is going to telescope. This is going to telescope to n cubed, I mean n plus 1 whole cube minus 1. So yes, n plus 1 whole cubed minus 1, that has to be equal to, first of all, just collect all these threes. So you'll have 3 common, and then you have n squared plus n minus 1 squared plus n minus 2 squared, keeps on going like that till you have 3 squared plus 2 squared plus 1, which is exactly what we want to find. Okay, then you have 3, and then you got this thing 1 plus 2 plus 3 all the way till n. Well, we know what that is. This is supposed to be n into n plus 1 upon 2, right, just from the previous proof. And then you got these ones. How many ones are there? I think n of them, so plus n, right? So now just we need to just deal with this algebra. Call this thing which we want to find as s. So we'll have n plus 1 cubed, what's this, n plus 1 cubed minus 1 is equals to 3s plus 3 into this thing, so like 3n into n plus 1 upon 2 plus n. All right, what's this supposed to be? This is supposed to be n cubed plus 3n squared plus 3n, right? That's correct. Oh god. Okay. So you got this thing, what, 3, okay, n cubed plus 3n into n plus 1 minus 3n into n plus 1 upon 2 minus n equals to 3s, right? I mean, nice, sorry. Then you got n cubed plus 3n into n plus 1 upon 2 from these two minus n is equals to 3s. Now we need to do some algebra. I mean, we need to simplify this first. See, that will give me 2n cubed plus 3n squared plus 3n minus 2n is equals to 3s. So that gives me 2n cubed plus 3n squared plus, what's this thing, plus n equals to 3s. So s equals to 1/3 of, wait, you got that upon 2 as well, so yes, 1/6 basically. 1/6 of 2n cubed plus 3n squared plus n, which can be factorized into n by 6 of 2n squared plus 3n plus 1. Oh, come on. Man, this cold is killing me. Then you got n into n plus 1 into 2n plus 6. Right. This is when you factorize this thing upon 6, which is exactly what we wanted. Alright. So that was a nice thing. That was the sum of the first natural numbers squared, right? So the next thing is going to be the first natural numbers cubed. So you got 1 cubed plus 2 cubed plus 3 cubed all the way to n cubed. We want to prove that this is actually equal to n squared into n plus 1 whole squared upon 4, right? So just do that in a similar fashion. We are going to find r plus 1 to the 4th power minus r to the 4th power. All right, what's that supposed to be equal to? That is supposed to be equal to, what is this thing, r to the 4th plus, you got 14641, right? Yes. So plus 4r cubed plus 6r squared plus 4r plus 1 minus r to the 4th. This cancels with that thing. Okay, so you have 4r cubed plus 6r squared plus 4r plus 1. All right, why, just wait a second. Okay, so what can we do with that? Just put the value of r as 1 first of all. So you will get 2 to the 4th minus 1 to the 4th is equals to, when you put the value of r as 1, you get 4 into 1 cubed plus 6 into 1 squared, 4 into 1 plus 1. Then you put 3 to the 4th minus 2 to the 4th equals to 4 into what's this thing, 2 cubed plus 6 into 2 squared plus 4 into 2 plus 1. Keep going like that till you eventually have n plus 1 to the 4th power minus n to the 4th power. That is equal to 4 into n cubed plus 6 into n squared plus 4 into n plus 1. I just sum this up, so that will give me n plus 1 to the 4th power minus 1. That is equal to 4 into our sum, right? 1 cube plus 2 cube plus 3 cube till n cubed. So this is our sum s, plus 6 into the sum of the first sum of first n squares is supposed to be n into n plus 1 into 2n plus 1 upon 6. Then you have this thing, 4 into 1 plus 2 plus 3 till n, 4 into n into n plus 1 upon 2. All right, and then you got these many ones, so n of ones. Right, so doing all that algebra is now up to you, and you should get with this thing s equals to n squared into n plus 1 whole squared upon 4. Okay, hope you enjoyed this video, and sorry for all that sniffing noise because I just have a cold. Yeah, I wish it gets away soon. Okay, thank you for watching the video, hope you enjoyed.